Yes, sir.
Okay.
So we can start at 11 sharp 11.
Sure,
Sure.
sure. बड़ी लंबी भी हो गई.
I think now we start. Time is okay. A very good morning to all
Yes,
of
yes.
you. Our today event guest, respected ma'am, Dr. Maryam Shojaei, Baghini from IIT Bombay, IEEE Censor Council UPC Chairperson, Professor V.S. Tripathi sir, IEEE Student Branch, MTTS, Counselor Dr. Anand sir, Vinay sir, respected faculty members, and most important, our participants. On behalf of IEEE Student Branch, MNNIT Allahabad, I, Pooja Sharma, take this privilege to welcome you all in this webinar. I appreciate your presence in this event from the bottom of my heart. IEEE is the world's largest technical professional organization. Being part of IEEE Student Branch, MNIT Allahabad, is a vibrant student branch. Currently, we have 8 active societies and over 70 student members. Collaboration, inclusive excellence, and collective efforts have made IEEE MNNIT Student Branch to reach new heights in the term of events and number of student members. Our IEEE Student Branch activities offers numerous educational, technical, and professional advantages of IEEE membership through special projects, activities, meetings, tours, and field trips. Now I request to Professor V.S. Tripathi sir say a few words of wisdom of our young professionals and motivate us. Sir, now is over to you.
Thank you, Pooja. Uh, I extend my warm welcome to all the participants in this webinar. Professor Maryam, most welcome. Uh, and I am thankful to IEEE and different organizational units of IEEE for their support to our activities. Uh, this is the theme of today's webinar is on focused on writing. Today is, as you know, today is World Book Day. So we decided to hold a webinar on focused especially on writing. In technical development, there are 3 dimensions. One is reading, the other is solving the problem, and the third one is expressing yourself. And generally, we as engineers skip the third part. We don't know how to write a precise paper. We don't know how to, and this is this I can say from my personal experience that this writing part, the expression part, is normally skipped from our teaching learning process. We know only one thing. We learn right from BTech, right from a very beginning. We learn something. We simply write it in the language which is already written in the books. So we don't know how to express our thoughts in a systematic manner, in an effective manner, and in the terms of how a problem is solved, how we compare our idea with others' ideas, how we can explain our results. We know the results, but we don't know how we can definitely and in a conclusive manner express what is specific in the result. So today we shall discuss these and many more aspects with our guest, Professor Maryam from IIT Bombay. She is a special invited guest in our webinar. Credit goes to Pooja. She has contacted. Professor Maryam is a distinguished lecturer in Censor Council. So I again welcome everyone in this webinar, and over to you, Pooja.
Thank you, sir. And thanks to Honor that appreciate me that I request her. And I really appreciate to Maryam ma'am. She easily joined us. Now I would like to invite our IEEE Student Branch MNNIT Allahabad member Aditya Pal to give a brief introduction about our guest speaker. Aditya sir, now is over to you. Thank you, sir. Now I request all participants, this is an interactive session. So you can ask any question and between the conversation, you just raise your hand and ask directly to the ma'am. Now I request to our today's event guest, Dr. Maryam Shojaei Baghini ma'am, to present her views on student and scientific writing. This is an interactive talk. Now over to you, ma'am.
Thank you, Pooja. Thank you, Professor Tripathi, and thank you all organizers and students for giving your time on Sunday. For me, it's almost like okay, but I don't know about you. So, how much you are active on Sundays on different activities related to your academic research as well as extracurricular. But anyway, let's have a kind of enjoyable interaction with each other during this 11 to 12 time of the Sunday. And I requested Pooja to make it interactive, because if it is not interactive and I only talk, I'm sure almost like 99%, it will become boring for audience. And
no,
I
this
think
is an interactive session.
yes,
Anyone
I
can unmute
know.
themselves.
Exactly. I'm saying that what is the motivation behind that? Motivation is really, and we are talking about scientific writing. So scientific writing actually starts with the scientific speaking, because even when a child grows, first she or he learns how to speak and then how to write. So therefore, it comes with the speaking. In fact, I want to start with one very common statement sometimes we hear from students, and we want to understand why we should say so. For example, when you ask a student, okay, so what do you think about this and why do you say this? Or what is the answer to this question? So there's sometimes they say, okay, I mean, yeah, this is, that is, but you don't hear a complete full sentence sound which can convince you. And then again, you ask more questions. And the person says, I know it very well, but I don't know how to convey the information to you. I don't know how to say that. So that's the question. The question is that whether that's true. If we know something, we will not be able to convey to others. That means just verbally, not with writing. So I personally believe that's not true. Sometimes we may have doubts in a fact. It could be related to anything. Right now we are talking about scientific writing, so I'm talking about scientific topics. In a scientific domain, we may always have doubts. We may not have even enough knowledge about something or enough information. So we need to learn more about it, which is fine. This is true. Learning is a continuous process. It never stops. So therefore, if we don't know it, so naturally we cannot completely talk about it. So therefore, scientific writing needs the way that we can convey the information simply when we talk. Because if we can convey it in a verbal manner, we can convert it into a writing piece of material. And to be able to convey a scientific fact or answer to the question or analysis of a problem in a verbal mode, we need to know all aspects of it relatively well. In other words, I call it digestion. We need to have digested it very well. So now I put a few questions. There are many questions. In fact, Pooja mentioned participants can ask questions. So I start actually asking questions. And in the meantime, I believe also it will be good if I put my views, but it's open to you as well. So I started my views with the simple, commonly observed kind of communication when you have with the students. And focus of today's talk is about the students. It's about you. So you are the topic of discussion. And of course, the way I heard from Professor Tripathi, most of you already are active, and I believe most of you are already good writers. So therefore, maybe what I say already is known to you. Therefore, and this is the actual fact about conducting class. You know, in typical, when you have a class, like 50% of the students are the students who want to really listen to you and then see what you say in addition to what they know and learn. 25% of the students may or may not listen just because they are anyway the kind of people who have too many things in hand to handle, and they can manage it well. So therefore, they may listen, they may not listen now because of the recording features. So they may listen to you later in recorded version of your class rather than the live version. And finally, 25% of the students really are not interested, in fact. And I mean, this is just a typical distribution. However, the number of students who are not interested, they are not really, that means they are not interested in learning. They may not be interested in that particular topic. Interest is another aspect which drives you in doing things very well, including expressing yourself, as Professor Tripathi mentioned. And when you express yourself in something very well and in something not, it's just because you don't have interest and therefore you may not spend time. Interest also is something which is a very important point that we need to consider, because nobody can force anybody else to work in a specific topic and have interest in a specific topic. But we need to learn some baseline. Say in engineering, say electrical engineering, in general electrical engineering, we need to have some baseline. So therefore, we need to train ourselves that, see, I need to get that baseline, even if some part of that baseline is not of my interest, but I need it. Therefore, if we think that we don't have interest, but we need something, still we go for it. So that's another factor. And finally, one thing which is extremely important, and not only in engineering, in everything, but in engineering it shows up also very well, is the thinking. Thinking is a feature that everybody has. And if you can think, you can express yourself well as well. So you need to be a thinker, you need to have the passion or interest, and you need to be curious. And you need to accept that sometimes we need to learn because we need to have a baseline, even though we may not have interest. Now the distribution of the students in the class will change if we accept these facts. And almost 100% of the students will listen because it's about having that baseline. So now going with this introduction, I start actually the questions. And one good point about today's discussion is that all of us can have this disclaimer. Nothing in this discussion is provided and developed by any AI engine. All of us are real thinkers and real people behind this discussion. So that's very important. In fact, I think henceforth, for every presentation, somebody has to put a disclaimer that no content of this presentation is produced by any kind of AI engine. And if it is, they have to give reference to that on that particular slide. That this also brings another aspect, which is maybe of question to you. If AI engines can write, what will happen for scientific writing? And that's also a very important question, but we will not talk about it right now. We will talk about it at the end. Right now, the topic of discussion is you, not AI engine. So let's go back to that. I share my screen, and then my screen is simple question. But I would like to hear from you. You can type in the chat box, but for me who shares the screen will be difficult to see. Perhaps Pooja or Aditya may read it. And I want to add some keywords in response to those questions so that I will not take the time of the session.
Okay, ma'am.
Thank you. So I'm sharing my screen. So I hope you can see my screen. Okay, very good. Let me turn off my camera. Anyway, it's not required. Okay, so let's start today's discussion. So the first question is, what is the purpose of scientific writing? Is the scientific writing a need or hobby? I want to know what is your opinion. Anybody, feel free to express yourself. I really like the statement Professor Tripathi said, because feel free to talk. See, if you talk, you can write. And if you talk scientifically, you can write scientifically. Okay, you may also just write, tell your name, that's it. Aditya, okay, Aditya, thank you. Okay, very good.
According to me, also, ma'am, initially when students starting BTech, MTech or there is research, there is a need of scientific writing. And after that, it becomes hobby.
Okay, so you believe that it is need only for the time that we are a student, we don't need scientific writing after that?
No. There are initial points where we start in this field now. So according to that, not as that we become researcher and then it's definitely our hobby and definitely it's become need in future also. That is not good if we stop writing in future. But initial stage is that we entered in the technical education, then it's the first step.
Yes. Okay. So therefore, say, imagine somebody like Professor Tripathi or me, who are not students. Do we need to really be involved in scientific writing?
But for professors also, I think this is also need for
Yes.
as per according to your profession. It's also need for to all of you, all the faculty members. So basically it's a
Exactly.
need to all.
Exactly. So it's really is a need of scientific profession. It could be at the student level. I call even a student a professional.
Yeah, it's a need.
It's a need for the students and for all scientific professionals.
Professionals. Dear all
So we,
participants, you also can write your answer in the chat box if you don't want to speak here.
yeah, and
If you want to
Pooja, you
speak,
may
then you can
just,
speak here.
yeah, and Pooja,
Yes,
you
ma'am.
please read it for me if they write. You
Definitely,
please.
ma'am. Definitely.
Okay, very good. So is there anybody who believes scientific writing is not a need? And feel free to again mention your view. Absolutely fine. And you can mention why you think so. Why scientific? Only put AI aside for now. Other than scientific writing by AI engines, other than that, suppose we are just talking about the students, scientific professionals, eventually about human. We are not talking about machines. It's very interesting these days when we talk about everything. We have to talk about say that we are talking about humans, not machines, continuously. Okay, so it seems that all of us agree it's a need now, and you know why it is a need. So suppose if you are told that to replace it with something else, will you? For example, no. Okay. So there, see, let's talk about PhD students, that you talk about PhD. So the question is, so in fact, this answer itself becomes a question. So the question is that, if it is a part of curriculum, why not to remove it? Why not to just say that, okay, we replace scientific writing with something else. So therefore, eventually, replacement of scientific writing. See, when something is curriculum, so you can always change it. It's not something that is prone to a kind of permanent feature of any activity. Scientific writing is one of the permanent, actually, features of the scientific work. But why, that will come later. But if you say it's a part of curriculum, that means it can be replaced. Therefore, it goes back to the
only for students, I think, ma'am.
See, if it is a need, it goes back to the first two answers. If it is a need, so therefore, it is not subject to change. That will remain as a need. Yes, right? So therefore, here, still, therefore, it's not a part of curriculum. It's actually a need.
Yes.
For everybody. Now, for example, for PhD students. Some other means, yes. Okay, I will tell you. That is true. That goes back eventually to the expressing knowledge and transferring it to others. But there are other means of doing that. For example, you can talk about your, like the way we record a lecture, right? Going back to a lecture. Scientific papers can be converted to lectures, right? So therefore, this could be a replacement, but whether it is the right way or not, that's another thing. So therefore, for now, I just keep it that way. It's still a need, but about replacement, we'll see. So this goes back also to one more aspect of scientific writing. Scientific writing is not new, right? Scientific writing has been with the history of mankind from the time mankind learned how to write and how to convey the information. Starting from the time symbols were being used for conveying information from one person to another person on the stones. So let's start from there. So that need and that requirement has not changed. So only I request audience, there is talking background, somebody is talking. If in case you need to talk, you may mute your mic and then later unmute. Yeah, so what I was saying, yeah. So this is a history of mankind. So, and it has not changed. It's very interesting. Writing as a means of transferring information and knowledge has not changed. Technology has changed. Writing on paper or writing on the display of a computer or reading from a candle, these are technologies, these are means. But the nature of the scientific writing has not changed. And I don't think it will change even in the future, because we as thinkers will not change. Thinking will remain with us, and thinking derives us, and the way of expressing ourselves and transferring our knowledge will remain verbal or written or other means. But why written forms are so convenient? Written forms are so convenient because you can always read a written material anytime, at any condition. Even if you don't have access to electronic device, you have access to a printed material. If you don't have access to printed material, you have access to some electronic device these days. So the convenience it brings. And on top of the convenience is the way of maintaining it, because scientific writing means converting the knowledge in the form that it will remain forever. It will not get destroyed. So at least naturally. Of course, in the past, there has been, there is, of course, in the history, there are many cases that a library is, for example, burned. And there was no backup of those books. A book is written only once, specifically books which were written manually. But those things are not really a case anymore. Even in electronic form, there are many, but at least 2-3 backups for every database, knowledge base, scientific resources like IEEE papers. So therefore, this knowledge will remain. There are people who are not with us. There are people who have been in this world, but when we were not on this world and we have not been born, but we have access to what they have written, and so for it's extremely important. You hear somebody who is not alive today, but you hear what he or she wrote. You read it and you understand it, just like he or she is talking to you. So that's so important. And imagine you become one of those people who is able to convey the knowledge or transfer the knowledge to another person in a very convenient manner. Now, convenience is not only from means, convenience also comes from the content. And that is in the way that why proper scientific writing is important. In fact, scientific itself has the word proper within that. I would say proper writing of scientific materials. Proper writing means we need to learn how to write. More often, those who have the natural talent of writing, they also write scientific articles better compared to those who don't. And talent is something which is, I believe that God has equally given to everybody some kind of talent. So therefore, it's kind of equal distribution. Some people have writing talent, some people have music talent. So some people have art talent. So there are always some talents. There is some talent with somebody, only we need to discover it. You need to discover it in yourself. Therefore, scientific writing, if it is not really talent, doesn't matter. What matters is that to learn how to do it. So it's a need, and therefore it's a need, therefore we need to learn how to write. It's a need for transfer of knowledge, and therefore we need to learn how to write. So this is the kind of conclusion of current discussion. So now how to learn, that's the important thing. So we can have, when we talk about machines are actually reflection of what we already know and we have learned. So we can have supervised learning, we can have unsupervised learning. See, you can have, I talk about my own experience, you can talk about your experience. See, I had that kind of, interest in essay writing. So always I was writing essay when I was a school student. So, and I love to write essays. And I love to read it for students in the class. But gradually, when it came to the scientific writing, then the first piece of scientific writing that you write is answer to the exam questions in the school. That's the first experience you have with the scientific writing as per the need. Why? Because you need to give that exam. Your need, not the need of scientific writing. So that is where if you write the answer properly, so teacher will give you a good mark or a complete mark because you have conveyed the answer very well. So that is the first experience of any kind of child with scientific writing. So answer to the exam questions is the first step towards scientific writing. The second step towards scientific writing is when you enter into the next level of education, which is the higher level of education beyond the school. So starting from BTech, you are not only answering exam questions, but also you write project reports. You write course project reports. You submit assignments, assuming you don't copy. So you submit assignments. Okay. So even if you copy, I think if you learn from your friend how he has written, I think that's good. That's good. You learn from him or her how she or he has solved that problem. That also is good. So that next time you can solve it by yourself and be proud of yourself. So that's also fine. As long as it helps, is okay. So that's why sometimes, I give some of the assignments actually as joint assignments to the students. I say that, see, I make your life easy. Instead of copying from each other, you just jointly submit this assignment. Groups of 3-4 students. So you can write one solution of 4 names. But please talk to each other and try to see that how you can solve it with each other. And then submit it. And when it comes to the project, naturally, during Viva, questions will be asked from all people. So therefore, they need at least to learn what they have done together. So it's okay. It's okay. It's absolutely fine. As long as you learn is okay. Okay, so then now we are almost like on the same page for this part. Fine. So now how you learn to write, it comes really with practice. Nobody is like learning, right? We need to learn how to write. So that learning is a process where when you repeat it, you will be more knowledgeable in that particular topic, and here the topic is scientific writing. So you need to learn. Fine. So now is how to learn. How to learn comes with practice. Therefore, it's very important. Let me write here, practice. Practice naturally comes. You know that why? Because you need to submit many assignments. Naturally, it's not just one assignment. You need to submit your project report. So therefore, naturally, it gives you enough practice, specifically when you submit assignments, then course project, then R&D project, for example, your BTech project. Then when you go to the MTech, for example, if you don't prefer a job, so you prefer to go to MTech or MS program, this requirement of scientific writing increases because You will reach to a level that you need to convey scientific results of your research. That's the next need, to convey it and transfer it to others. Therefore, you need to learn. So it comes, if you do it in the school way, proper way, write answer to the questions in the exam properly, one step you have come up. Next step is during your BTech, you write your assignments properly. So you have gone one more step up. And this is the way you learn. It comes over time. And of course, if you are a passionate student that likes and loves to write, which more often is driven by the talent, then you can go into different activities, even write articles when you are a BTech student. So this naturally driving you. But I'm talking as a generic case for everybody, not specific cases when the person has the passion of writing. Okay, so now we move to the next part. In fact, a part of it is already answered. Is the scientific writing a part of knowledge dissemination process? So I hope I have written the spelling correct. These days we are relying only on machines to correct for us. So let me convert this to transfer, because now we talked about knowledge transfer. I used the same words that we used. So this, of course, already we discussed. You need to convey your knowledge to others. Even could be your friend, could be your teacher, could be your faculty guide when you are a BTech student, and could be even tomorrow the paper you write and goes to one of the journals that everybody in the world may, not everybody, but many people in the world may read it. So therefore, the answer, of course, is yes. And it's a part of knowledge transfer process. In fact, if without scientific writing, we will lose a very important part of knowledge transfer process. We cannot convert articles to recorded lectures. It's not very convenient. Convenience comes. So comes with the transfer. So it's not only transfer of knowledge, but also it comes with convenience. You are in the train and then you are opening a printed article. Sometimes it's much more convenient. It's flexible. Till our displays become like papers. Paper still is the very convenient way of having. And also, that as far as the eyes are concerned, no technology still can compete with paper printing because of the contrast it creates, and it has a complete opaque with white background substrate, which is the paper, white paper. So that's why still the technology-wise, as far as the human eye is concerned, paper is the best way. However, paper has its own problems of weight and other things that So therefore, it's okay. So it goes. That's why Kindle or devices similar to that for book reading or paper reading are designed in such a way that they resemble the paper technology. Okay, so I think here we don't have much to discuss because it's relatively obvious. But if any one of you has any crazy idea or interesting idea that anything can replace scientific writing for transfer of knowledge, you may come forward. Okay, good. So therefore, this is well understood. Now, this is what I talked to you a little at the beginning. Scientific writing and thinking power are related. I say yes, definitely, but elaboration goes further. See, when you say that, I know it, but I cannot tell exactly. I don't know how to say that. So why, if we know something, we don't know how to say that? Is that even possible? If I know something, but I cannot convey it to you. I'm talking to you, I know something, but somehow I don't find the words for it. In my mind, I know it, but I don't find the right words for it. Is that the reason I cannot convey? I cannot talk about it? talk about something that is very well settled in my mind. I don't have any doubt about it. Sometimes it is. Sorry? It happens. Can you tell me why? So therefore, again, answer will come with the question. So let's say that, is it true that we know a fact very well, but we cannot talk about it well? And hence, we can't write about it well. So that means that I want to write an article. I have done a research. A part of this research, I faced a problem. I solved the problem. I want to write about that problem and solution, but I don't know how to write it. I know it, but I don't know how to write it. So before that, we talk about, can I talk about it? Suppose if I ask you, what problem you faced? Okay, give you an example. For example, you have a circuit in the lab, and then you see that the output is not coming the way you want. You check, and then you notice that, for example, one of the inputs is loose. This is the first thing we check, whether there is any connection which is not very well corrected, or it is wrongly connected. So that's the first thing we do. And the next thing would be to go into the details of the circuit, for example, whether there is any loading or not, if there is a loading, how that loading happened, and so on. So it's a kind of series of experiments to figure it out. But then you say that, see, I can tell you this is the loading effect, but I cannot explain it for you, because I ask you, what do you mean from loading effect? And then you say that, see, this is a kind of, I notice that it's drawing a lot of current. Then I ask you, okay, so what do you mean from drawing a lot of current? Why? There should be a short circuit path or a low impedance path to the ground. How did you find that path? Did you find that path? You know, we need to ask more and more questions. But when you talk about scientific writing, you don't have the luxury of answering the readers with their questions. Therefore, you need to write in such a way that all questions that the reader may ask you already is in your mind. Okay, this could be a question for the reader. Either I have to give reference, or I have to open it up, or I have to draw a diagram. So my point is that when we say, I know something, but I cannot talk about it, I think it's more about that we don't know it well, but we think we know it well. I mean, this is my personal opinion, but you may repeat what you said, maybe with a little elaboration. Give an example. For example, what could be the case when you know something very well, but you cannot talk about it, and therefore you cannot really put it in the form of a scientific piece of material. Could be a, say, set of equations, could be an equations with explanation of equations, could be just words, a few words, a paragraph. Okay, so is it more kind of scientific rather than, and technical rather than non-technical, in the sense that suppose, for example, your circuit was supposed to give the gain of, say, 1000, but you see it is giving you gain of 2000, that bad. But you don't know why. Is it what you mean? Okay. Okay. Okay, interesting. Sure. Yeah, I agree with you. For example, if somebody asks me to explain in a language other than English, because there are too many technical words in English, really it will be difficult for me also. I agree with you. Language is a fact that could be the reason, but let's for now assume you are free to speak in any language that you are comfortable with. Because that is something that naturally is not related really to scientific writing, because in scientific writing, finally, we need to write in any language. Let's say English, because most of the words are naturally, even if you write in any other language, we have to use so many English words. But that is okay. That is okay. Let's assume you have freedom and then you can write or speak. In fact, speak with any language you want, because when it comes to scientific writing, at least I have noticed the students are more comfortable with English writing, but because of the keywords and because of the terms, which are anyway known to them. But let's assume you are talking about, for now, verbal communication, and you are talking to with any language that you are comfortable with. Will be still a problem? Yeah. Suppose if you are given the choice to talk with any language that you are comfortable with, will you still have problem, or you see this becomes easier? Okay, so therefore that's fine. See, don't worry about it, because these days you have voice to text conversion, right? So therefore, voice to text conversion is a technology which can actually help us. Because when I write or when I talk, anyway, in both cases, it's me. When you talk or you write, in both cases, it's you. So you are not copying anybody else, or you are not using anybody else's words. You are using your own words, but in a verbal form rather than written form. Let's for now assume that you use that technology. You convert the voice into text, and then suppose you speak with a specific language, convert it to the script in that language, and there is another tool which does the translation. So two levels of technologies come to help you. But content still is yours. Content is coming from your mind. No technology can replace it. By the way, AI also cannot replace it. AI cannot replace what can come from your mind. Unless if you tell it in advance to the AI engine, that is equivalent of saying it to somebody, and that somebody will use that and then will come up with a better version of it, or the same thing. Same thing is a copy, and better version comes with the thinking and elaboration and adding his or her knowledge to what you said, and then make an elaborated or modified version of what you said, which is fine, as long as it is in the context of scientific norms. But nobody can replace your own thinking and your own way of doing a scientific research, and therefore scientific communication. Let's call it scientific communication. Even right now, don't be worried about writing. It's all about communication. Either it's through speaking or through writing. Let's limit it to these two for now. Speaking in any language and writing, or writing in any language. There is one more angle to what you said, and that is what I want to bring it up here. So therefore, the question here is, how much do you rely on simulations in your research? Because it has a direct relation with scientific writing. I will tell you why. In percentage, for example, you can mention, suppose if consider the whole project as, say, 100%, whatever you need to put there as an effort, thinking, examination, running tests, running simulation, solving equations by hand, design by simulator, taking help eventually from simulator for design, and so on. So put all these pins together in your work, say antenna design. So how much in percent? Okay. Okay. I will make it 60 to
Yes,
70%, right?
for me, yeah, ma'am. 70 to 80% sometimes, maybe, if we are
Wow.
totally depending on the simulation.
Let's make
If
it
we have a
60
good
to 80.
simulation, yeah.
Okay. So 60 to 80% you rely on simulation. You know, this is a fact. Simulation, believe me, is one of the problems. And I put a exclamation mark because you may be surprised. If you don't use simulation in a right way, and this is really one of the problems. Simulation, if you use simulation a lot in your work, a few things happen. Simulator gradually will eventually cover your thinking, eventually will mask it. Simulation can easily mask your thinking. So therefore, you don't consider simulation is the core of the research. Of course, without simulator, you cannot complete a research. That's absolutely correct. But if the simulation becomes the everything in the research, that will really mask your thinking. So one of the reasons, in fact, sometimes you cannot express is because you use simulation too much as a replacement of reasoning. So therefore, the problem is this: simulation results become eventually way of reasoning. Simulation results can't be way of reasoning. Simulation is for validation of your reasoning. Reasoning cannot be simulation results. Simulation results only should validate your reasoning. Simulation is a tool. It should not replace your thinking. Now you may say that how I can do reasoning without simulation. I'm not saying you don't do any simulation and do only reasoning, but keep in mind always, say when we go to antenna design, there are, say, ways to control. One way would be reading textbook or writing textbook. Reading textbooks, excellent.
Reading.
Reading textbooks and learning baseline models. The model that you have with your antenna may be very complicated, but still there are baseline models for basic antennas. So you may start from there. So these baseline models are very important. When you learn, then you analyze them as well. question always comes from students, not question. Actually, sometimes also is a kind of complaint from them. We don't have time. We don't have time. We have deadline. So what you are expecting us will take a year from us. So see, the question is not, you don't need to read the entire textbook. You need only to learn how to be selective reader. So this is very important. Means how to discover parts which are important for you. No need to know each and everything and read in each and everything. This is very important. So this comes with practice, but believe me, when you do that, your foundations become strong so that you really see the time you spend. I always tell my students also, because they say that, see, this simulator XYZ shows these results. So, but first of all, the first question is that how do you know those results are correct? So therefore, how do you, that's why don't take it for granted. Because you don't know even if they are correct or not. How do you prove they are correct? What if you have given something wrong in your setup or in your inputs? So naturally results are something that it doesn't make any sense or it's so good to believe. You know, it's other way around also. Whenever students show something which is too good without any problem, so we are sure that it can't be true. So therefore, too good or too bad, both seem something is wrong in here. Too bad, not really bad in the sense. What I mean is that bad in the sense that you get frustrated seeing that you expect something to be very simple to work with very well predicted results, but it doesn't come. So that's something where you get frustrated. So you need really to learn how to be a selective reader, learn the basics. When you know the basics, you can at least have a first order estimation of what you expect from simulation. It will be very good. This is something that you need. How to use baseline models to estimate. It's estimate. You may see 20% difference, but 20% difference is fine. But at least you have some idea, expected pattern or values or say trend, something you want. So if you can quantify it, so that will help you. And you know, then it becomes really a very interesting way of working and learning. And believe me, if you go that way, scientific learning, scientific writing naturally will come. Because you have gone through this procedure in a very systematic way. Now you know the baseline models. You can draw that baseline model diagram. You can write the basic equations about that. And that is where you will write. You will start eventually automatically getting into the scientific writing. And then paper writing becomes really straightforward for you. At the end of the day, paper writing is the report of what you did and what you taught and what you got, and then how you analyze them. All you are doing, you are conveying that experience in the form of a paper to the readers. So therefore, you don't need to do more than what you have already done to write a paper or write a good report, which can be read by many, many people, many, many years, even centuries. Who knows? So therefore, I think this, in my opinion, this is what I have seen, and it's valid about everybody, it's even about us. If today I stop thinking and I rely only on simulations, imagine that students will not be able to learn anything. That's why in the class also I try to avoid things which are based on the pure simulations. And most of the, like half of the semester, even I don't allow students to go to simulators. Everything is pen and paper and model and mathematical analysis. See, in engineering, one thing it is also is very important. Engineering is based on mathematics. Many students are forgetting this fact, and this is affecting the scientific thinking which will be followed by scientific writing. Engineering is based on mathematics. We came to engineering because we loved maths and physics. If we try to deviate from those basics, so we lose our strength. And believe me, if you follow that, no AI engine can replace you. And you don't need to use AI to write papers. You may take help from AI engines for writing papers. It's okay, and refer to those engines officially. Refer which part of this. But this AI engine cannot replace you for doing that scientific project. It's you. And you know why? It's very simple. Now we have concluded that thinking is very important, right? For scientific work. It's very important for any. How many people in this world? Say 7 billion people exist on this earth. 7 billion minds. And whenever you accept a project or a research project as, say, a PhD or MTech student, or even a BTech student, always something different comes out of it. 7 billion minds can give 7 billion ways of looking at same problem. And there is no limit for that. Even if tomorrow 7 billion becomes 70 billion, this continues. Why? Because human brain doesn't have an end. It's infinite. There is no size limit for the thinking. You may get tired of thinking, that's fine. That's our natural property as compared to machines. But it doesn't mean that your thinking power has stopped. Your thinking power will stop, or at least will get degraded, if you don't use your brain. The best food for your brain is thinking. And if you become a thinker, you will be a good learner, you will be a good writer, and you will be a good scientist, you will be a good engineer, you will be good in everything you do. Doesn't matter what you do. Even you will be excellent in your hobbies, in your whatever you are doing as extracurriculum activity. You will eventually, everywhere, you will have thinking. And you believe me, sometimes these simple facts come from experience in life. When I was 10 standard student, I had a friend who was 9 standard student. And she had the habit of walking during the break in the school playground, and then usually like sometimes talking to herself. So sometimes I was kidding and saying, I see, sometimes you are just going away from other friends and then just talk to yourself and then walk. So she said that I'm thinking, because I think thinking is the gift God has given to us. You know, from a 9 standard friend, I learned a lesson that still till today I remember that. And still the picture and the image of that day that she was standing in the middle of the school playground and telling me this fact, I was thinking, wow, look at this girl. So how she thinks, she's a philosopher. But then I noticed that she's right. Actually, thinking is our superpower. So no machine can replace that, no AI engine. At the end of the day, everything is our mind. And this thinking power is infinite. Only thing is you need to reuse it. And I have a colleague in the department, one of our senior faculty members, who always say that when you think, good thinking, you feel your eventually scalp is heated. You feel heat. This is because your neurons are really dissipating energy and consuming energy and thinking. And that's why it's good to learn how to focus, how to think, and how to be methodological in your research. Therefore, the main thing right now, everything you may have, the only thing which is something that you need to know is that expressing simulation results is not reasoning. For reasoning, you need to come up with a kind of mathematical proof, which could be very basic proof, is okay, but something which explains. And that is also related to intuition. Intuition also can be improved with thinking. They are all connected. And that is where you naturally will get into the scientific writing. However, there are some skills also still in writing which are not based on only this procedure. That comes with looking and reading more and more, say, short scientific articles, magazine articles in your field. Magazine articles are better than research papers because they are giving you facts that you may know also already, many of them, but they are organizing them very well. And by reading that, you will see how they have the writer has organized it and then has written it in a very nice way. And of course, no matter how much we are good in scientific writing, whenever we want to start writing something new, again, we need to think about it. We cannot write something new without thinking about it and organizing it and having 2, 3, 4 versions of it. And that means that every time we write, something new is coming up in our own writing. That means we are also becoming better and better and better, and it doesn't again have any end. So this is, eventually we have reached to 12 o'clock. So these are my main points. The other points are actually, I talked about. Only question I put forward in front of you based on today's discussion is, can we outsource a scientific writing to AI tools? Answer to this question is not very clear. It's a kind of question which needs discussions. And in fact, articles can be written on this topic in different domains. But one thing I can tell you is that you can always have an assistant who has capability to help you. AI tools at the end of the day are capable assistants to us. But no assistant can replace us because everybody is unique, with a unique way of thinking and learning. So nobody can replace you. It's simple this way, if you go philosophically. And I think I have, and of course, this answer to this question is, of course, yes. And how much time spent depends on, yes.
Madam, actually, I have a question.
Yes.
When we start writing any scientific paper, then what are the fundamental steps we use by which our paper is more scientific? What are the fundamental steps in terms of
Good.
research, in terms of scientific?
Very
The word
good
scientific
question.
focus on the.
Yes. How to start writing and then so that your paper becomes really a scientific paper. See, let's assume you have done an experiment. We go with that. And you want to convert that experiment results and analysis of that experiment into an article. And convey it, eventually transfer it to others. First thing you do is that no need to be worried anything. You just start writing about your experiment. Only your experiment, nothing else. It's like lab report. And for writing an experiment, so naturally, first is what was the purpose of that experiment that you did? That is what you will start. The second thing is that what you needed for that experiment, means practically in the lab, for example. If it is simulation, still, what kind of simulator you needed? What kind of capabilities that simulator should have? And therefore, first you need the purpose, you know the problem. The second, you know the setup and the tools that you need, whether it is in the actual experimental work in the lab or it is in simulation. And the third thing is that how you did that experiment, step by step. Exactly, you just write what you did. See, writing what you have done is not difficult for you. Writing what somebody else has done is difficult. But writing what you have done is not difficult. And don't worry about the grammar and other things if you are not really fluent in grammar. So you write it. It's okay. Don't worry about grammar. That also there are tools which help you to write with proper grammar. But you write the way that you yourself are happy with your writing. And you are just writing your experiment, nothing else. And then you write the results. However, you also write the problems you are facing. See, students always don't write what are the problems they are facing and what are the wrong results they are getting or what doesn't work. So I always ask them, see, don't do that because 50% of learning is not about what works. It's about what doesn't work. and why. So therefore, if you did something which that didn't work, either it was your mistake or it was really fundamentally wrong, it's okay. You write it. You write, I made this mistake. In fact, you are writing your experience on an experiment. This is a very good thing to help yourself to find a methodological method for the scientific writing. Now, when you write how you did that experiment, because you remember what you did today and what you did yesterday and what you did the day before yesterday. And if you don't remember, which may happen easily, specifically if your experiment is time consuming, suppose you do it over a span of 1 week every day, so you may forget. Write every day at the end of the day the main parts of the work that you did that day, what you observed, what worked, what didn't work, what was your mistake, and what was your learning, even your learning. Now, after 7 days, for example, you have results, you have completed, done. You put these pieces together and you go with, say, 3-4 versions to organize them. At the end, flow is the same. What was the problem? What I prepared in the lab to run the experiments on this problem, about this problem, or simulations. These are the settings that I had to do, but I forgot, and therefore I learned I had to do. So I did it finally. And this is what didn't work because of those things that went wrong. And these are the results that I got. This is the model that shows that it is possible to predict. So therefore, even when you run an experiment, even in the lab, don't forget about this. This is important fact about basic baseline models and analysis of these baseline models. This is very important, extremely important. So even for experiments, so basic models, see that at least if you get the results in, for example of antenna, is it at least 20-30% maximum different from what you expect? So therefore you have already that. And then that experiment, if you write just that experiment, so you have written the first important part of your scientific document, whether it is an article, report, or anything else, or even a chapter of a book. You have written that. Now, rest of it depends on what you want to write. If it is a report, so you need not much to add. If it is an article, you need to add an introduction about the domain of that experiment. So you can write it later, that introduction, an article. So in my opinion, if you want to write a scientific article or report, you write what you have done very well. Rest can come. Rest is only simple learning. And write the abstract of what you have done always at the end and conclusion at the end. Because when you write everything, then you will get the picture. And then you write the abstract. In fact, abstract is something which is read first by the reader and it is written at the end by the writer. So it's like introduction of the PhD thesis or preface of the PhD thesis or books. They are written always at the end by the authors, but they are read by the readers at the beginning. Because for the writer, you will get the full picture of what you have written at the end. And for the reader to get the full picture of what you have written, he or she needs to look at it at the beginning. So you just go with that, and then over time, you will become fluent in reading and writing, both. For scientific writing, we need also to be a good scientific reader.
Yes, madam.
These two come together. So be a scientific reader, be a thinker, you will be a scientific writer as well.
Thank you, madam.
Okay, thank you everyone. So Pooja, my talk is over. Unless if there is any question, we can continue.
Thank you, ma'am. Dear participants, if you have any doubt, any query, or you want to ask anything from our guests, you can please ask. Or you can write your question. If you have any question, please in the chat box. Write in the chat box.
Maybe then I unshare my screen.
Yeah, you can stop your.
Okay, I think the advantage of interactive sessions is participants ask questions during presentation, and this, in my opinion, it is more useful.
Yes,
They
madam.
don't
Yes.
need to. Yeah, they don't need to wait till end.
Yeah, ma'am.
Because I also
Still,
don't
we are.
like it. I always ask questions at the middle of presentations. Sometimes people don't like it, but it's okay.
I think no one is having any question.
Okay.
So thanks to all of you.
Okay,
Now,
thank you.
Pooja,
Thanks, everyone.
Pooja, I have to
yes, sir.
some points related to this discussion by Professor Maryam.
Yes, sir. So before you proceed, there is
From
some question
yes,
from our participant.
yes, please,
Ma'am,
please.
ma'am, I can read this question for you. Am I audible to you, ma'am?
Yes, yes, please.
Yeah, the question is from Tilakdhari Singh, sir. In the scientific writing, many times we have to face plagiarism problem. How can it be resolved?
Okay, sure. Okay, so see, this is one thing that I was telling the students, that you start writing what you have done. So if you write what you have done first, not last, that's the point. See, because scientific papers, which are, now we are talking about research papers. I think the question is about research papers. And of course, even if it is not research, even if it is an article, still. The point is that if you write about your thought process or your own experiment, so it naturally will be different from anything anybody else has written till now. What remains more often, which brings this plagiarism, is that if suppose you use a model which is already reported and you are referring to that model, so equations may be same equations. This is not plagiarism, this is just reuse of knowledge. But because plagiarism tools don't understand it, they reflect it as plagiarism. So simple thing you can do is that you can write the equations by your own again. Because there are some features in this plagiarism tools which need to be improved, but they need to bring a lot of AI aspect. Because practically is like a human should look at the two papers and compare. But if it is copy-paste of sentences, so naturally that will happen. So that anyway, we will not do that. You may say that, see, sometimes when you read a paper, the way an author has written some sentences to explain things, for example, specifically when they review the background work in the introduction section, even it has happened for me. I find it very nice, very interesting. So I try to write that way. But here I need to be careful. So I need to use synonym of the words. Don't use words which are very common. Use words which are not very common. That helps to avoid this problem. If you find some sentences which are really nicely explaining something which is again done by others, you are not here, and this is introduction of the paper. We are talking about what others have done. We are not saying we have done it. It's not plagiarism. But still, when we talk about others' works, we have to write in our own words. We can use somebody else's words for somebody else. So therefore, the best thing is, I think one technique that can be helpful is to use synonyms which are not very common. This will not be captured by plagiarism tools. And at the end of the day, when we go with the introduction section also, because sometimes you see many things are captured there. So you try to write with the way you think about a paper, or you think about some of the, previous articles you have read. So that will help you. Write it again, you think about them and write about them as if you are explaining it to somebody else. This also helps. For example, if 2-3 friends sit together, they explain for each other their thoughts. So, you hear your friends and then they hear you, they tell something to you. So this discussion, which could be just for 15 minutes, you can convert it to say 4 to 5 lines of scientific writing with references, which can become one paragraph of your introduction. So these are some of the techniques which help to avoid plagiarism.
Okay, ma'am. Thank you. Thank you, ma'am.
Thank you.
Ma'am, one question is from my side. What is the best way to start a research for a new researcher? What is a good approach or what is the right direction? How we start in a correct manner?
Okay. So are you talking about BTech or MTech or PhD?
Basically, I'm asking about PhD student. If a BTech student want to start in this field, then how we proceed? Or he, she.
Okay. Oh, for PhD, you mean how to move from BTech to PhD? How to create that kind of foundation? See, BTech, I think if you are talking about BTech students, I think it's almost everywhere. So there are two opportunities which are good for BTech students. One is R&D project and one is the BTech project. Because if you take these two kind of projects very seriously, as if you want actually to publish a paper out of it. See, when you want to, if you like to do something, you like to do research, you don't know how to start with it. You start from something which is compatible with your eventually knowledge, experience, and passion. So you start with that R&D project, but you put a goal for yourself, a target. I want to convert my work to a simple article, either in a conference or in a, say, magazine at least. So if you target for a conference paper, naturally it will drive you, and that will help you, because one thing about research is subject to a lot of innovation. Therefore, there is no way of going, okay, you follow A to Z, you will do research. We cannot dictate it, but there are some kind of, I would say that, frameworks which can help to do research. But the best thing is that you take a R&D project or you define your BTech project based on your interest. Interest is a very important factor in research. If we don't like something, we cannot spend days and nights on it. Research needs that. Research is not defined by starting at, say, 10 a.m. and ending at 5 p.m. That doesn't define research. Research is a continuous process, and naturally it becomes a part of our life over time if we like to be in that domain. So therefore, you don't need to be very systematic, but you need to be continuous. Be continuous.
Maintain consistency.
And maintain the consistency and keep deadlines for yourself so that you can reach to the target of conference submission. Because conferences more often have deadline. And target conferences, which is not easy to get papers through. Not very difficult also, because we are talking about BTech, but not very easy. So at least, their acceptance rate is something not really more than 60 or 70%. So at least you know that you need to compete with somebody else so that your paper will get through. So that will help you to naturally move. It will drive you, believe me. I mean, when you start, it will drive you, because we are like, learning and doing. We are really, the same experience now is implemented on the networks. Continuously, they are learning this AI network. So that's the same process anyway, naturally, it's with us. And you can, of course, take inputs from people who are around you anytime you face any problem.
And one more question is, if for a PhD scholar especially, this question is, how we target to transaction journals? If we write some paper, and how we target to publish our paper in that journals, transactions?
Okay.
How to approach them?
See, one thing which is very important is that don't be afraid or frightened that, and the stress even. Don't be stressed that, I have to get this paper in the transaction and I don't know how to do it, how much time. You do a good research, transaction will come. Believe me. So now, see, you be very systematic in thinking. Yeah, it means that you don't lose your thinking and intuition, and analysis power. Then I can assure you, you will be able to come up with a transaction paper. The reason is because transaction papers are based on solid thinking of the authors. And then have perseverance in doing something which is not done by others, small problems which is not solved by others, or if you want to slightly improve what already exists. If it is about the design, you may want to make a more efficient design. If it is about an automation, you want to add to the automation which already exists. So therefore, define that problem, and for that you need to have relatively a good idea what is already reported. And then be a little also patient and define the problem in such a way that it will give you scope for the next 2-3 years. Because by the time you do the project, I'm talking about PhD, by the time you publish and by the time that goes to reviewers and reviewers give you comment, it will take its own time. So therefore, you really try, every time you see a problem, consider it as an opportunity. So a challenge that you face, something doesn't work and you see there are bottlenecks, these are opportunities. And it naturally happens. I don't know, it's the nature of the research. Perhaps nature itself has this research, understanding what is happening in nature, or what can be made better, naturally has the nature of rolling. You will be automatically rolling, it's not like really you target and then you need to do something special. You just do your work. Don't worry about that transaction. That automatically will come because your work becomes a unique work. As long as it becomes unique, you can take it to the transaction. It's not a big deal. It can be done. There are some little tips and tricks, but those tips and tricks are not like 80% of the things. I would say 80% is this, and 20% of the list can come a little, how to write it, how to project the problem, so that the reviewer will understand it is a problem, how you have ensured you have done enough literature review so that you have not missed any paper which is compatible with your work, and so on. So these things can be later. And then, of course, also, they ask some papers like contribution of each co-author. So if you have co-authors, dedicate some work to them and then bring them into that research. That naturally will, 3 brains work better than 1 brain always, right? So that also helps a lot.
Okay. Thank you, ma'am.
Yeah, thank you. All the best.
Thank you, ma'am. Is there any query from our audience or participants? I think there is no other query now.
Okay, so then we can conclude.
So I can conclude the session.
Before you conclude, Pooja, let me
Yes, sir.
share some takeaways for a crisp understanding of our participants. The basic thrust on scientific writing was, which was highlighted, was on your thinking capacity and regularity of your work. Means we should focus on continuous regular work and utilize our cerebral capacity in its fullest. Have confidence in yourself. If you follow these simple psychological traits, you will be able to deliver good scientific papers. And as far as this last point, transaction papers is concerned, it is not a big deal. It becomes big deal because we don't think properly. It is a hype made in institutions, in hostels, and among the students, that these are something very extraordinary. Actually, your thinking is extraordinary. If your thinking is extraordinary, you can do extraordinary things. So with these words, I would like to say thanks to Professor Maryam. Thanks a lot, Professor. I think
Thank you for the invitation.
your suggestions were extremely these are actually I think 24 students are presently in this meeting, and
32
all of them are
No, 30 students, sir.
30.
30.
Okay.
Right now.
30.
Yeah, total 30.
Okay.
Yeah.
so and all of them are, I think, PhD. They all are PhD students.
Excellent.
Yes, sir.
So and some of them are first year students. So these thoughts will be very much useful for them.
Yeah, all the best to all of them.
So it is very timely received suggestion. It will change their perspective, since because this COVID, they were not able to have a good amount of interaction. So now we are able to have this academic sort of interaction and all these discussions. So I am sure that it will enhance their knowledge base and their outcome.
Yes, definitely.
Thank you, ma'am.
Thank you. All the best. It was my pleasure to interact with all of you.
So, thanks to all participants. Before leaving the meeting, I request to all the participants, please switch on your camera so we can click a picture.
Thank you.
Okay, the picture is done. Thanks to all of you. Thanks to ma'am especially for coming in this, attend this event and motivate us and guiding us in the right direction.
So
thanks
thank
to
you,
all of you.
Pooja. May I request you please share the photo with me as well?
Definitely, ma'am.
Yeah,
By today evening, I will share you.
Okay, thank you.
Thank you so much, and once again, thanks to all participants. Without you, this event is not possible. Thank you, VST sir, for guiding us. Thanks to all.
All the best
everyone.
to all of you.
Thank you, ma'am.
Thank you. Bye.
Thank you. Thank you.
Thank
Oh,
you.
bye.
Bye.
Thank you, ma'am.
Bye. Thank you. Bye.